right, so last time we talked about molarity. So in this section, we're going to talk about how you calculate and express concentrations as percent solutions. So you can have three types of percent solutions. You can have a mass percent. So this is the mass of the solute to the mass of the solution. You can also have a volume of a solute if you have a liquid, and the volume of the solution. So remember, the solution contains both the solute and the solvent. And then you can also have a mass to volume percent, where you have the solute as mass and the solution measure as volume. So for our percent concentrations, if we have solid solutions, concentrations are usually expressed as mass percents. So you'd have the mass of the solute in grams over the mass of the entire solution, which is going to contain both the solute and the solvent. So you get the actual percent of the solution by multiplying this times 100. If you have liquid solutions, concentrations will often be expressed as volume percent concentrations, where you'll have the volume of the solute in milliliters over the volume of solution in milliliters multiplied by 100 to get the concentration. You can use really any volume units that you want to calculate the percent concentrations. They just need to be the same as the overall solution. So if you're doing mass concentrations, you could use milligrams of solute as long as you have milligrams of solution also being utilized. So the units have to be the same when you're looking at these guys. For percent concentrations that are mass to volume, you're going to have grams to milliliters as your concentration units. And this is very typical to have solutions presented as mass to volume percents when water is being used as the solvent system and you're dissolving some solid compound in that water solution. This would be the typical way that you would express percentage. So one thing, since you can have these different representations of percentage, this has to be indicated. So if you have a problem, like a word problem, or you're given a percentage of some solution, it should tell you what type of percent solution it is. Is it a mass? Is it a volume? Or is it a mass volume percentage? This has to be given to you so that you know how that measurement was calculated. So again, the solution, the volume of the solution, is the final volume of both the solute plus the solvent system. So anytime you would actually be making a solution in the lab, you would start out by taking the appropriate amount of solute, weigh it out, and place it in a volumetric flask or another mixing device. You would add enough solvent to dissolve the solute, and then you would add additional solvent to reach the final volume. So the final volume has to be the entire solution. The solute and the solvent together make up the volume of the solution. All right, so let's work this first problem. So we have a 4-gram sugar cube that is dissolved in a total volume of 350 mils of a teacup full of 80-degree water. So we want to know what is the percent composition by mass to volume. So we know that mass to volume percentage, our equation for that is going to equal the percentage equals the mass of the solute in grams over the volume of the solution in milliliters, and you multiply that by 100, and that's going to give you the percent. So that's exactly what we need to do here. So we have our mass of our solute. It's already in grams, so we can just put that in there. So we know our percentage is going to be 4 grams of sugar, and our volume is in milliliters. We already have milliliters, so this is all right too. So we can put in 350 milliliters, multiply this by 100, and this should give us our percentage. So this would equal a 1.14% solution, sugar solution. So the nice thing about doing percentages is that you don't really need to know anything about the solute that you're adding. You don't need to know the formula. You don't need to know the formula weight. You don't need to calculate any of these things. You just need to know the actual mass. So you need to be able to weigh it on a scale to make a percent solution. So that's one of the nice things about using percent solutions instead of molar solutions. They don't take as much background knowledge. So let's do another one. So in this one, we want to know what is the composition, mass to mass, of a sugar solution if you have 8 grams of sugar dissolved in 400 mils of water at 80 degrees Celsius. So we need to know the mass to mass, right? So this is a little bit different than the last one. We still have volume given for our water. So we're going to have mass of solute, and that's measured in grams up here. And so we're going to need the mass of the solution on the bottom. And that's also going to need to be in the same units. So we'll say grams. This is going to be our percentage, mass to mass. We know our mass of our solution is a combination of the solute plus the solvent. So we already know the mass of our solute is 8 grams. And now we need to know the mass of the water, right? So, but we're not given the mass of the water, we're given the volume of the water. So we know the volume is 400 mils. So our volume is 400 mils of water. We need to know how much that weighs. We need to know. And we can use our density to actually find that out. So we know the density of water at 80 degrees, they give us that, is going to be 0.975 grams per milliliter. So we need to do a conversion. We need to convert 400 milliliters into the gram weight. Grams is already on top, so we'll leave it there. So we'll say our 400 mils times 0.975 grams per milliliter is going to give us our grams of water. So this is actually 390 grams of water. So we can put that and fill that in here as 390 grams. And so we know that our mass of our solute then is going to be 8 grams. And that's going to be over 398 grams of solution. Multiply that by 100, and that should give us our percent of our solution. So this one would equal a 2% solution. So that is our final answer, 2%. All right, so this is another important concept when we're thinking about percent solutions that you might end up having to do. You might end up having to make a solution, right? So you need to be able to calculate how much of something that you need to make up a fixed volume of any percent solution. So most of these guys that you would be making are probably going to be mass to volume because you're going to be dissolving things in water. This is going to be a water solution where you're dissolving sodium chloride to make a 12% solution at a volume of 300 mils. So maybe you need to make this as a saline solution for a patient or something. So you want to be able to get the correct concentration. That would be very important, especially in a medical situation. So we need to be able to define what our percent mass to volume means, and then determine how many grams we're going to need of our solute to make up a final volume of 300 mils. So we know a percent mass to volume solution. We need to remember that definition, that percent solution is going to be grams of solute over the volume in milliliters of the solution. So we know our total volume is going to be 300 mils, and this is multiplied by 100 to get the percentage. So that's essentially what our percentage actually means. So what this is saying is that a 12% solution means that you have to add 12 grams of our solute in 100 mils to get a 12% solution. That is by definition. So if we know this, we can compare this to something that has any volume over here. So this is actually setting up a proportion. So we know this proportion to be true for a 12% solution, and so we can calculate this for any other volume. So we know we want to have 300 mils in our volume, and so our question is, how many grams do we need to add to that 300 mils to keep this proportional ratio? So if we have proportions that are going to be equivalent to each other, this comes from our A over B equals C over D equation, and we can do cross multiplying to actually solve for an unknown. So you could say this is also equivalent to saying A times D equals B times C. So we're going to do that for our equation as well. So you've got 12 times the 300 mils. So we can say down here 12 grams times 300 mils is going to be equivalent to our X grams times 100 mils. And then we can solve for X, essentially. So if we go ahead and do that, we say 12 times 300. So this would be 3,600. We're going to divide both sides by 100 mils. So right now we've got grams and mils up on the top. If we divide this side by 100 mils as well, that will cancel this guy out. It's going to cancel mils out as well, and we'll be left with our answer in grams, which is what we want to find out. So in this case, we can see that we're going to need to add 36 grams of sodium chloride to a total of 300 mils to get, this is going to be equivalent to a 12% solution, and this is mass to volume. So setting up this proportionality and being able to use that is a very important tool. We could solve for any one of these variables that we don't know. You could solve for the mass, but you could also solve for the volume. So I could say, if I have 12 grams of substance and I want to make up a 6% solution, how many mils of water do I need to add to that to get that final volume to be correct? So you can end up solving using this A over B equals C over D, because those proportionalities should be equivalent to one another.